Today we're looking at solving polynomial equations in factor form. The first thing we want to talk about is writing equations in standard form versus factored form. A polynomial is in factored form when it is written as a product of factors. When you hear the word product just means multiplication. So if it's in factored form, we have two things that are multiplied together, whereas standard form has pluses and minuses. So if I have standard form, which is x squared plus 2x, that is x squared plus 2x, whereas if we write it in factored form, we have x multiplied by x plus 2. X squared plus 5x minus 24 is equal to x minus 3 times x plus 8. So we have two things that are multiplied in factored form, and all of them are added in standard form. When one side of a polynomial is in factored form and the other side is 0, we're going to use the zero product property to solve the equation. If we have the solution of a polynomial equation, those are also called zeros or roots. So sometimes it will say find the zeros or find the roots or find the solutions of a polynomial, and all of those mean the same thing. Now, if I were to take a star and times it by 0, that would equal 0 because anything times 0 equals 0. If I were to take a heart and times it by a star and say that equals 0, and I were told that the heart is equal to 3, well, if that heart is equal to 3 and it's timed by a star to equal 0, that would tell me that the star would have to equal 0 because 3 times 0 equals 0. So let's try one more. If I were told that a square times a triangle equals 0, and then I was told that that square is equal to 8, the triangle would have to equal 0 because 8 times 0 equals 0. So let's look over at this zero product property. If I am told that A times B equals 0, then either my A has to equal 0 or my B has to equal 0. So let's look at number 1. I have two things that are multiplied together. I have x, and that is multiplied by an x minus 1. So since we have two things that are multiplying together to equal 0, then either the x has to equal 0 or the x minus 1 has to equal 0. Now we're going to solve both these for x. If we look at x equals 0, that's already solved for x. We can't do anything to that. Whereas the x minus 1, we can add 1 to both sides and we get x equals 1. Now if I were to check this, I could put 0 times 0 minus 1, if we plug 0 into this equation, 0 times negative 1 gives me 0. If I put a 1 in, I have 1 times 1 minus 1 equals 0. 1 times 0 equals 0. So no matter which one I pick, they will give me 0 in the end if I have x equals 0 or x equals 1. We have, on number 2, we have two things multiplied to equal 0. We have 3t could equal 0, or t plus 2 could equal 0. We're going to solve each one of these for t, divide both sides by 3, and t equals 0. 0 divided by 3 is 0. If I minus 2 from both sides of the equal sign, I get t equals negative 2. And no matter which one I put into the equation, we will still get the answer of 0. If I put 3 times 0 for the first part, and 0 plus 2 inside the parentheses, if we plug the 0 in, we get 3 times 0 times 2. And anything times 0 is going to equal 0. Now if we put a negative 2 in, 3 times negative 2 times negative 2 plus 2. Negative 2 plus 2 gives us 0. And 3 times negative 2 times 0 is all going to equal 0. Looking at number 3, we're going to set both of these equal to 0. So either 7 minus 4 has to equal 0, or z minus 6 has to equal 0. So we're going to add 4 to both sides of the equal sign, and z will equal 4. On the other equation, we're going to add 6 to both sides of the equal sign. And so z will equal 6 there. So my two answers are going to be z equals 4 or z equals 6. Let's plug this in so we can see why this works. If I plug 4 into the equation everywhere there's a z, I get 4 minus 4 and 4 minus 6. 4 minus 4 is 0, and 4 minus 6 is negative 2. And 0 times negative 2 equals 0. If I plug 6 into the original equation, I have 6 minus 4 for the first parenthesis, and 6 minus 6 for the second parenthesis. 6 minus 4 gives us 2, and 6 minus 6 is 0. Well, 2 times 0 equals 0. On number 4, we have 2x plus 7 and 2x minus 7 equals 0 if we multiply those together. So since they're multiplied, we can say 2x plus 7 equals 0, or 2x minus 7 equals 0. To solve this for x, we subtract 7 on both sides of the equal sign, and we get 2x equals negative 7. We divide both sides by 2, and x will equal negative 7 over 2, or negative 3.5. On the other side, on the other equation, we're going to add 7 to both sides, so we get 2x equals 7, and we divide by 2, and x will equal positive 3.5 there. Looking at number 5, we have x minus 1 squared. Now, if you remember, x minus 1 squared is equal to x minus 1 times x minus 1. We have two things that are set equal to 0, x minus 1 equals 0, or x minus 1 equals 0. Well, these two are the exact same thing. So we can add 1 to both sides of the equal sign, x equals 1, and the other equation is the same, where we get x plus 1 again. So since those answers are the same, that is my only solution, where x is equal to 1. Let's look at number 6. We have x plus 1 times x minus 3 times x minus 2 equals 0. So we're going to have 3 equations this time. One of those 3 factors have to be equal to 0 for this whole thing to be equal to 0. So x plus 1 equals 0, or x minus 3 equals 0, or x minus 2 equals 0. So what we're going to do is we're going to subtract 1 from both sides on the first equation, add 3 to both sides for the second equation, and add 2 to both sides for the third equation. So x equals 2. So we have 3 answers: x equals negative 1, x equals 3, or x equals 2. And all 3 of those, when you plug them in, will set one of those factors equal to 0. If I put a negative 1 in, it'll make that first one 0. If I put a 3 in, it will make the second parenthesis set 0. And if I put a 2 in, it will make the third set 0. The next section talks about factoring polynomials using the greatest common factor. To solve a polynomial equation using the zero product property, we need to get it in factored form so we can set each piece equal to 0. You may need to factor the polynomial. Factoring reverses the distributive property. So we look for the greatest common factor. This is a monomial that divides evenly into each term. So on number 7, we are finding the greatest common factor, or the GCF, of the two numbers. So the GCF is the biggest number that will divide into both numbers. So I'm going to make a factor tree of 18. I have 2 times 3 times 3 gives us 18. 9 and 5 are 45, and 3 and 3 make 9. So we have 2 3's on both of our numbers, so we're going to multiply those to be 9. So 9 goes evenly into both 18 and 45. 6 and 6 goes into 36. We're going to break that each 6 down to 2 and 3. So we have 2 times 3 and 2 times 3. 24, I have 6 times 4, and 6 breaks down to 2 and 3, and 4 breaks down to 2 and 2. So each set has 2 sets of 2's. We have 2 2's on 36 and 2 2's on the 24. They both have a 3 in common as well. Now the 36 has an extra 3 and the 24 has an extra 2. But what we're going to do is we're going to take those factors that are the same and multiply them together. 2 times 2 times 3 gives us 12. Let's look at number 9. We want to think of the biggest number that goes into 5, -10, and -15. So 5 goes into 5, 10, and 15. So if I take the 5 out of the first term, the only thing that is left is the x squared. So 5 times x squared, when we distribute it, gives us 5x squared. On the second one, we're looking for a number that multiplies to give us a -10. 5 times -2 gives us -10, but we need an x, so we have -10x. 5 times -3 gives us -15. So this would be the factored form of 5x squared minus 10x minus 15. On number 10, 8 and 24. Well, I want to look at that 8. 8 will go into both 8 and 24. And then we have y squared and y. The first one has 2 y's and the second one has a y. They both have a y that will go in evenly. So my greatest common factor is going to be that 8y. So 8y times y gives me 8y squared, and 8y times -3 gives me -24y. This would be the factored form by taking out the greatest common factor. Now 8 and 20, I'm going to break down 8 to be 4 and 2 and 2 and 2. 20 is 2 times 10, and 10 breaks down to 2 and 5. Well, they both have 2 2's. 2 times 2 is 4. So we're going to bring that 4 out. Now I have 3 x's for the first term and 2 x's for the second. Both of them have 2 x's. So we're going to factor out 4x squared. Now I'm looking for what times 4x squared gives me 8x cubed. 4 times 2 gives me 8, and x squared times x gives me x cubed when I distribute that. 4 times 5 gives me 20, and 4x squared times 5 gives me that 20x squared that we're looking for up top. On number 12, I have 5x cubed minus 3x squared. Looking at 5 and 3, there's not really a number that goes into both 5 and 3, but 1 will go into any number. So if there's not a number that goes into both of them, just put a 1. So the first half has x cubed. We have x times x times x, and the second one has x times x. Both of them have 2 x's. So we're going to pull the x squared out. X squared times 5x will give me 5x cubed, and x squared times a -3 will give me -3x squared. So when we write our answer, we don't need to put the 1 on the front. We will just end up with x squared times 5x minus 3. On number 13, we are solving the equation. So we have a squared plus 5a. We're going to take a out. Both of them have an a in common. We're going to take that out, and then we write what's left. A times a gives us a squared, and then we're thinking what times a will give us 5a? Well, that will be a 5. So we're going to add up plus 5 to the second set of parentheses, and that's going to equal 0. Well, now we use the zero product property to write a equals 0 or a plus 5 equals 0. A plus 0 is done. We don't need to, that's just the answer. But we do need to solve for a in the second equation. We're going to minus 5 from both sides of the equal sign, and a will equal a negative 5. And both of these answers will give us 0 at the end. If I plug 0 in, 0 squared plus 5 times 0 equals 0. 0 plus 0 equals 0. If I put in a negative 5 squared plus 5 times a negative 5, negative 5 squared gives me 25, and 5 times negative 5 is negative 25. That equals 0, so that one checks out as well. Looking at 3x squared and negative 9x, what's the biggest number that will go into both 3 and 9? That will be 3. And then we have x squared and x. Both of them have an x in common that we pull out front. We put our parentheses, and we have 3x times x gives me 3x squared, and 3x times negative 3 gives me negative 9x. This is all equal to 0. We're going to set up two equations where we have 3x equals 0 and x minus 3 equals 0. On the first equation, we divide both sides by 3, and so x equals 0. And on the second equation, we add 3 to both sides, so x equals 3. Those will be the two answers that will make our equation 0. Now, if I plug in 0 into the original equation, I have 3 times 0 squared minus 9 times 0, and that will equal 0 minus 0, which is 0. 3 times 3 squared is 27, and negative 9 times 3 is 27. 27 minus 27 is going to give you 0 as well. So both of these answers work. Now, 15 is in the wrong form. To use the zero product property, we need to set everything equal to 0 so that we can use that. So if I have 4x squared equals 2x, what I want to do is I want to minus 2x from both sides of the equal sign. This will give me 4x squared minus 2x, and that will all be equal to 0. So next, I want to factor out the greatest common factor. 2x will go into both pieces of that equation. 2x times 2x gives me 4x squared, and 2x times a negative 1 gives me negative 2x. So I set both of these equations these pieces equal to 0. Either 2x has to equal 0 or 2x minus 1 has to equal 0. We divide both sides by 2, and x will equal 0. On the second equation, we add 1 to both sides of the equal sign. 2x equals 1. Then we divide by 2 on both sides, so x will equal 1/2. On number 16, first thing we want to do is get this polynomial set equal to 0. Now we can do this two different ways. First way is I could take the negative 2x squared to the right side, or I could take my negative 10x to the left side. Now if I bring my negative 10x to the left side, my very first number is going to be negative. Now I can use that and bring out the negative, but I usually like to not have negative numbers as my first number. So I'm going to do this two ways, and you'll be able to see how I'm going to get the same answer either way. So this is going to be way number 1, and then I will do way number 2 in a second. So first way I'm going to show is I'm going to just take this negative 10x and I'm going to take it to the other side. It's a minus 10x. Opposite of minus is a plus 10x. So if I add 10x to both sides, I'm not changing it, but what happens is the negative 10x and the 10x cancel out to give me a 0 on the right hand side. So I have a negative 2x squared, and I have a plus 10x. Now I want to look and see what they both have in common. Now you never want to have a negative in the first spot of a quadratic. So I'm going to divide the negative 2 out of both pieces. They both also have an x out of each piece. So I'm going to pull a negative 2x out of both of these. If I divide each piece by a negative 2x, the negative 2's cancel and one of the x will cancel, so I'll just have an x left. So I'm going to have an x. Now, a negative times a negative equals a positive. So when you pull a negative out of the equation, it's going to flip the sign. So now instead of a plus, I'm going to have a minus here. And a negative 2 times a negative 5 equals a positive 10, and an x times no x just equals an x. Now I have them both set equal to 0, so I'm going to set each piece equal to 0. So I'm going to have negative 2x equals 0, and my second one is x minus 5 equals 0. I have a negative 2 times something equals 0. Negative 2 will never equal 0, so the x has to equal 0 there. X minus 5, the opposite of minus is plus, so I add 5 to both sides. And so x equals 5 and x equals 0, and those are our two answers. Now I'm going to do this the same question, negative 2x squared equals negative 10x, but I just want to show you what would happen if I take it to the right hand side instead. So let's say I add 2x squared to both sides of the equal sign. They both have a 2. We're going to pull the 2 out. They both have an x. We're going to pull that x out. I will be left with an x minus 5. I set both pieces equal to 0. Now, if you have a 2 times an x, the 2 will never equal 0. So we just are going to set the x equals 0 and the x minus 5 equals 0. Add 5 to both sides, and my x equals 5 and x equals 0. So we get the same answers on both sides of the equal sign, but I would say that pulling it so that you have positive number in the front is just a little bit easier than the other. It's a lot less likely for you to make mistakes.